Hello everyone and welcome to lesson number 2 of my deep learning course. In this video we will dive into the fundamentals of deep learning, understand how it works and how it differs from the usual programming approach. So without further wait, let's get started. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. Welcome back. So as you can see, I'm logged into my Jupyter lab. If you haven't seen lesson 1, please go and take a look. I will leave a link in the video description. In that lesson, we set up the environment so we can all follow along in the same, using the same environment. Okay, so first thing we need to do is to go to my website at lesson 2. I will leave you the link in the video description. And we scroll down and we can copy this command. Then go back to our Jupyter lab, open up a terminal, paste that command, and then type unzip and the name of the file. So lesson2.zip. So as you can see, it has already downloaded the file, and give it a little time to refresh. And here we have it, lesson2.Jupyter Notebook. So from now on, we are going to use mostly Jupyter notebooks. I will create them first, then put it on my website, and we will use this procedure every time so that we can go along and go through these Jupyter notebooks, and meanwhile I will also explain them. So for now we can close this terminal, and we can double click on this file. I will increase a little bit the size on the screen so that you can see better. Okay. At this point, a little bit about Jupyter Notebooks. So if you're not familiar, you can get used to it. First, on this, the upper part, we can see the kernel. That's very important if you are crashing or if you're having problems or you want to restart the Jupyter Notebook. What you need to do is restart kernel and clear all outputs. This is in case something goes wrong, you can always restart everything fresh. This is an interactive notebook. That means that every cell or block of code, as you can see here, can be executed independently, and that's why we need to restart the kernel in case something is wrong. Everything is code basically, like as I mentioned. If we double click, we can see what is inside. This is, for example, a markdown, and as you can see at the end it's just text. If you want to execute a code, you can press Ctrl Enter or the button up here. If you want to add a new cell, you can click on the plus button, and here in this case it's code, but you can change it again to markdown, and markdown is nothing else than text at the end, so we can type this is a simple text. Press Ctrl Enter, and here's the file. If you want to remove this line, you can just click on the scissor up here and it's all back again. Another thing to remember is that we have virtual environments. So we have been creating those virtual environments in the lesson 1. So if you click up here on top right corner, there is this TF2 and it's also written switch kernel. If you click here, you can select on which virtual environment you want to use or which kernel you want to use. For this specific Jupyter notebook, we need to use TensorFlow 2. So you have to click on TF2 and click on select. So first I have a quick announcement for you guys. I just started a Patreon account, so if you guys like my content, please support my work. You will also be able to speak directly with me, so in case you need some advice on how to start a career in this field, you can directly ask me. So let's start by the video of this lesson. So you can see this block of code. If we execute it, Control Enter, is going to show the YouTube video. In this case, it's showing the lesson 1. Lesson 2, as soon as I upload it, and I will change again this file. So for you guys, when you're going to download it, you will be able to see the actual lesson 2. Make sure that you subscribe and activate the notification bell. You can easily do it also from the Jupyter Lab interface. Okay. So let's start by what is artificial intelligence. So artificial intelligence is the technology in machines that are able to carry out tasks that we would consider smart. This is what I would say is my definition of artificial intelligence. And what do I mean by intelligence? The intelligence I refer to is nothing else than multiple algorithms combined together to solve some specific task. So with those two short definitions, you should get a hint about this AI, where it's all going. It's all about algorithms. Now, let me clarify right away for the people new in this field, artificial intelligence is not machine learning nor deep learning. So do not think that this is all the same thing. In fact, we can achieve some artificial intelligence applications without machine learning. So if you go to a job interview, very likely they're going to ask you what is the difference between machine learning and deep learning. Do not say that it's all the same thing, because it's not. Machine learning, I would say, is a series of algorithms and techniques that can be used to achieve artificial intelligence, and deep learning is a subset of machine learning. I would, in a short, very short sentence, that's what I would say. So now let's go into what is the difference between normal programming and machine learning. So what does a programmer actually do? He designs algorithms. Depending on the requirements, a programmer designs an algorithm to solve a specific task. Machine learning instead is a collection of algorithms and techniques that creates the specific algorithm automatically by just providing many examples. So it's not going to be the person sit down and design the algorithm, it's the machine that figures out the algorithm. How does it do it? By providing lots of examples. So let's make some examples that explain better this concept. Let's say a customer wants an algorithm that takes an input X and maps it to the corresponding value Y, and it gives us some examples of XY pairs. This could be a simple scenario where the customer wants to control the intensity of an LED based on some input. Now, I know this is not what happens in real scenario, but just take it as an example to get started. So in this cell here, we just make sure that we are running into TensorFlow 2 virtual environment. So we run it. It's just going to take a little while because it's loading the TensorFlow library. As you can see, it's done, no error, so it's all good. If you had another environment, it would have prompted an error message. In that case, you would have just clicked up here and changed the kernel and relaunch everything. So let's start from the data itself. Let's say we have our input values and our expected output from the customer that look like this as a list or array. And so that we can assign the two variables. And then we have the input 1.0, the expected output is 0.5, 3, 1.5, 10, 5, and so forth. as you can see, it's pretty intuitive that the output y is nothing else than half of the input. As you can see, 1 divided by 2, 0.5, 3 divided by 2, 1.5, and so on. So we will define a function that does this. So we will call my function, which takes an input x. Here we just make a quick type checking to make sure that x is a float. And then we create the algorithm, the very complicated algorithm, with this line. So we multiplicate the input times 0.5, and we get our y hat, and we return the y hat. Just for you guys to know, in machine learning it's common to call the inputs as x, the labels as y, and the predicted output as y hat. It's not a must, it's just naming convention, so that you're start to getting used to those words. So let me know in the comment down below, how would you get to this solution? So this was pretty intuitive, but how would you guys have solved this problem if it wasn't that intuitive? Let me know in the comment down below. So let's run this function. Here is just define the function. Now we need to create a simple function, another simple function that compares the output of our algorithm and the expected output y, so the labels. Why do we need to compare it? So that we can add some error, so that we can quantify this error. So we take as inputs y and y hat. Y is the expected output, y hat is the output of our function. We do again some type checking. And then this is our function, error function. So what is it all about? It's nothing else than the absolute value of y minus y hat. Why this? So that we can always get a positive error. And by checking the difference between y and y hat, we get the how different are those two outputs. And then we return the error value. Okay, so now it's finally time to check. Oh, forgot to run it. Now it's finally time to check how are the performance of our algorithm. So we iterate through each x-y pair with the zip method. Then we predict our y hat using the function, and we compare the error. And we print then the error at each time. So we run it, and we can see that all 5 times there was 0 error. So we can say that it's very good. Now, this is really, really simple. But if I would have given you different values, how would you have solved it? Let's say those are the new values. So with an input of 1.9, the output is 1.58, 3, 2.9, 10, 11.3, and so forth. How would you solve it? Again, this is not that intuitive as before. We can solve it with deep learning. Now, this is a total overkill, so in a real scenario, I would definitely not use deep learning for such a simple task. But again, just taking it as an example to understand it, to get started with deep learning. So let's start by what is a neural network. A neural network is nothing else than a series of neurons interconnected. So we're basically trying to simulate the neurons that we have in our brain. But in this scenario, what is a neuron then? It's a simple equation, a linear function. Y is equal mx plus b. You might remember this equation from school, where x is the input, m is the slope, and b is the intercept. Now let's create a super simple neural network using low-level TensorFlow. If it seems complicated to you, do not worry. We will use later on in the next video some higher level APIs that do everything for you, It's really just like one line of code. But I think it's also necessary to understand a little bit how it works in detail, deep learning, and not just use it as a black box, as I've seen many times. So let's start by defining our class. So in the constructor, we will define two variables, m and b, like in the equation. We have to use TensorFlow data types, because since we use TensorFlow, we will stick with all TensorFlow functionality. And we initialize the weight, or m, to 2.0 and the bias to 0. In practice, this should be with random values. So usually, not always, but usually, the weight, or m, has to be initialized with random values, and the bias should be 0. But it really depends on the scenario, how you construct your network, and so on. There is not really like a fixed rule. We will talk about a weight initialization later on in the course. Then we define a call function, which basically output the equation like before. So given an input x, we multiply it by m, we add b, and we return it. So now here we create an instance of the class, and we want to make sure that it works as expected. So we give an input, which is 3.0, and the expected output has to be 6.0, since 3.0 times 2 plus 0 is 6. So we run this code. And as you can see, there are no errors. Now, like before, we have to define a loss function. What is a loss function? It's basically the error function, like we did before. This time we will use again tensor operations. We need to stick with tensor interface. So we will define a function. We will call it loss, in which we have it takes as input y and y hat. Again, y is the label, y hat is the output of our network. And the error is again the absolute value of y minus y hat, but this time is averaged across all data. At this point, we will not pass one data point at the time, we will pass all of them together, and then we will average this error in this line of code. Why do we do this? Because we can use vectors, so we will use all the data as a batch, as a group all together, because that's how deep learning works. You can also use one at a time, but it's slower, so it really gets the performance by giving big chunks of data and parallelize all the operation together. So at the end, we just use matrix multiplications. So we can run this code. Okay. Also here, no problem. Now we define a training function used by our network to train itself. The procedure works as follows. Given an input x, we predict the output. Then we calculate the loss between the expected output and the predicted output. We compute the gradients, and we update weight and bias with a small learning rate. Now, this might sound really a lot together. So I also put a video that explains this concept very well. If you don't understand the math behind it, is fine. Just focus on the concept. Again, by executing this code, we can see this is a lecture from Andrew G from Coursera, and he explains gradient descent very well here. And we'll also explain what is this concept of learning rate. So you can go and check out this video because it's really intuitive. I find it very intuitive. Okay, now it's time to design our training function. So our training function takes the model as an input, so the instance of our neural network class. Then the inputs, so our x's as a vector, so that we can use it as a batch. Same for outputs, which is our y, again as a vector, and then a parameter, which is the learning rate. If you've seen the video up here, basically you will see that the learning rate is how much the network is learning at each iteration. We can summarize it in this way. There are some drawbacks. Learning too much has some problems. Learning too less is very slow. We will figure it out later in the course, and also you will be able to play around with those values at the end of this Jupyter Notebook. So let's describe what's happening here. We have to go to those lines. Here we calculate the loss, and then we just print as an information what is the current loss. We compute the gradients by taking the loss and by passing also our variables, so m and b. And then using gradient descent, in this case is really from scratch. So what we do is we subtract, so we take a step. The step is, how big is the step is based on the learning rate, towards the negative of the gradient for the weight, so for m, and for b the same. And then we print again the new values of m and b of our model. So we can launch this code, and now we have to repeat this process for many iterations, steps, and we will see the results. First, I convert input values and expected output as TensorFlow constants. Again, we need to stick with TensorFlow. Then we can run this. And as you can see, at each iteration, we get a loss, a certain value of the loss, and certain values for m and b. And as you can see, at each iteration, it reduces the loss and it changes a little bit the m and b values by a tiny bit at each iteration, until we reach a value of roughly 0.453 in loss. And as you can see, the weights of m, so the value of m, we started with 2.0 and now we get to 1.171. And with the bias, we started with 0 and we get to this very tiny value. So this iterative process, it's what's happening in deep learning. If you get this, that's already most of how deep learning works. Those are just the fundamentals of how deep learning works. So as a reference, now we got our theoretical equation. So m is 1.171 and b is minus 0.048799. But to give you a reference, I created those values, those inputs and outputs, based on another equation. So we can see it here, we can run it. I gave for the outputs, I multiplicate the inputs by 1.2, and then I subtract 0.7. And as you can see, now leave a little bit of error, which is due to approximation. It's really matching, so the error would be 0. But it's not exactly what our network has found, as you can see. We have some differences. Now, this is very important to understand that deep learning is basically a function approximator, nothing more than that. So we can get to a lower loss and potentially reach this the error of 0, but in real life we don't have such a easy scenario with such values, so which is clearly a very simple equation. Usually there are some noise, there are some errors, there is something unpredictable. It's not so clean and simple. But that's important. So deep learning is a function approximator. So you approximate some function. Okay, so now we reach the end of the Jupyter Notebook and the end of this lesson. I left in this cell the code for training multiple times the neural network every time from scratch. We can run this code multiple times. For example, we can launch it once, and then we can, for example, change the number of steps, launch it again, and again everything will restart. So what I want you to do is to experiment. Try to change the number of steps and the learning rate and see how the neural network performs. And also, as a bonus question, can you identify what is the limitation of this neural network? As a hint, think of the equation mx plus b, which is a linear equation. Let me know in the comments down below the answer to this question, and also what are the results and what you see by running this code here. So I thank you for now, and I hope to see you in my next video.